André Dekker, born June 20th, 1974, is a Dutch medical physicist, author, and academic who is a professor and head of clinical data science at Maastricht University, Maastricht UMC+, and Mastro Clinic. He also holds the position of Chief Scientific Officer at Medical DataWorks. Dekker's research centers on federated fair data infrastructures, AI for health outcome prediction models, and applying AI to enhance patient and citizen health. He has written of 250 articles and is the co-author of the book Fundamentals of Clinical Data Science. Education and early career. Dekker pursued a Master of Science in Applied Physics at the University of Twente and obtained another master's degree in Technology Design from the Eindhoven University of Technology in 2000. He completed his PhD in medicine in 2003 and undertook a residency in radiotherapy medical physics at Mastro Clinic from 2003 to 2005. Career. Dekker served as a radiotherapy medical physics resident at Mastro Clinic from 2003 to 2005, later assuming the role of medical physics head and member of the management team until 2010. He was the head of information and services, member of the management team at Mastro Clinic from 2010 to 2015, and scientific director at Mastro Innovations from 2010 to 2018. He has served on advisory boards of organizations, including the European Society for Radiotherapy and Oncology, Hanner Fund, MD Anderson, Novo Nordisk Foundation, Luxembourg National Research Fund, and Petermann Cardiac Center. He serves as the head of clinical data science at UM's Medical Center, while concurrently holding the positions of full professor of clinical data science, chief scientific officer at Medical DataWorks, and medical physicist at Mastro Clinic. Media. Dekker co-led the ProTrait project, focused on creating a unified database for evaluating clinical data from patients undergoing proton treatment, which was featured in Dutch media outlets. He emphasized AI's potential to enhance decision-making in radiation oncology by facilitating shared decision-making between physicians and patients in an imaging technology news piece, and discussed ethical AI solutions benefiting patients through academic, healthcare, and technology partnerships in an interview with Innovation Origins. He was invited to the American Society for Radiation Oncology to share his vision on the future of AI in the radiation oncology field. In addition, he addressed researchers from NITC and doctors from MVRC Sarai, highlighting the significant potential of applying machine learning methods for early cancer detection and treatment. Research. Dekker has focused his research on constructing global fair data sharing infrastructures, employing AI to develop outcome prediction models from that data, and utilizing those models to enhance patient outcomes. Dekker, alongside Peter Cubbin and Michel Demontier, co-authored Fundamentals of Clinical Data Science, which delve into topics such as personalized medicine offering insights in a healthcare-optimized style, without requiring mathematical or coding expertise. His research on the increasing significance of clinical decision support systems in radiation oncology discussed the multi-stage process involved in developing robust prediction models, emphasizing the critical role of predictive models in optimizing treatment outcomes. In a collaborative study, he proposed a system for characterizing and classifying oligometastatic disease. Dekker explored radiomics, particularly in non-small cell lung cancer imaging, addressing the challenges of extracting quantitative features from medical images to develop diagnostic, prognostic, or predictive models integrating biological and medical data. Collaborating with a team of researchers, he conducted a radiomic analysis of 1,019 patients with lung or head and neck cancer using computed tomography, CT, imaging data, identifying prognostic radiomic features that showed significant power in independent datasets of the cancer patients. Additionally, in describing the concept and potential of radiomics in cancer research, He and his collaborators proposed guidelines to enhance the scientific integrity and clinical relevance of radiomics investigations. Furthermore, his systematic review assessed the reproducibility of radiomic features used in cancer imaging for clinical decision-making, noting that feature stability is influenced by factors such as image acquisition settings, reconstruction algorithms, and pre-processing methods. Dekker introduced a method for analyzing plethysmographic signals to identify heart rate variability parameters linked to respiration rate, leading to an improved pulse oximeter functionality for non-invasive respiration rate monitoring. His development of an apparatus resulted in an approved patent for monitoring secondary physiological processes by analyzing optical signal variations. He then presented a method utilizing photoplethysmography to gather physiological parameters, involving filtering and analyzing pleth signals to identify components of interest for determining respiratory parameters. Awards and Honors 2019, Sir Godfrey Hounsfield Award, British Institute of Radiology 2020, Healthcare Award Computable.